Last unit to a close, I've got a couple of things that I want to offer to you. The first one is with aeolian deposits. We have two really significant aeolian deposit locations within the United States. The first is Imperial Sand Dunes, and if you're a Star Wars fan, you'll know this is where they filmed all of the great sand dune scenes across the series. This sand dune formation, it really is the inside of the Grand Canyon. So as the Grand Canyon was being carved in the Colorado Plateau area, the Colorado River was transporting that material downstream and transporting it into this particular region over time and permitting this material to become available in this 30-degree latitude zone, which is hot and dry, desiccating that material out. It was then fine grain enough that it was able to be picked up and then transported into this area just west of the original deposition zones and created this lovely stretch of moving sand dunes to the very south portion of the state. The second is White Sands National Monument in New Mexico. Very substantially large deposition zone that extends quite a number of miles across. So if you are a dune fan, then maybe these are two locations that you might want to check out. With that, the last thing that I want to offer you this semester then is something called loess. And loess is really, really critical to the establishment of modern civilization as we know it. Loess is a fine grain glacial deposited material. So the glaciers, which we talked about in the last module of this unit, erodes and grinds material up. And we talked about glacial flour as producing these gorgeous lakes. That flour gets distributed globally. And that flour, part of that flour produces something called loess. And loess has found its way into low reaches in delta areas and what has become floodplain areas. So we now know what a floodplain is. Floodplain areas in significant places across the world. Now, loess is a contiguous layer across the terrestrial landscape of our planet. But over 10,000 plus years, it's been able to be moved into the lower reaches through those transportation processes that we discussed in this unit on geomorphology. So we've amassed a very significant volume of this stuff in areas where we have grown crops. The nice fine nature of this material and the rich mineral sources within it that came out of the ground rock from glaciation has been a staple in establishing the agricultural revolution 10,000 years ago. Exceptionally great for cultivation. You add organics to that soil, and we as a species have been very successful in maximizing the cultivation out of this particular loess. So if it really wasn't for glaciation and the production of loess, we wouldn't have an agricultural revolution to speak of, and I don't know where our species would be. Here's the modern global distribution of significant loess deposits. If we really take a look at these regions, we find that places in China, the bend through here in Europe and Asia, and then the Central Plains, as well as down here in Argentina, are all significant cradles of agricultural stability for feeding people. Loess in these environments has situated on grassland environments as well as forested landscapes to produce a large volume of food production. So really, really critically important. Of note, as geographers, now that you have become, should question a few things here. Now, Europe, for one, has spotty loess deposits across its landscape. And if you think about Europe and think about how Europe was created, we've got lots of material coming out of the Alps and coming out of the fracture belt of those Eastern European countries, and moving this loess into these linear features like the Rhine River and the Danube. And so that's what we're finding, loess in Europe is across these riverbeds. And because of its collinear relationship with those rivers, Europe was able to be really fertile as a result. The other big curiosity that I hope you would pay attention to is the great volume amount of loess that is happening in the Sahara Desert and the Sahel, which is just beneath the Sahara. And then what, if you remember from earlier in this unit, here in Australia, Australia is mostly a big arid desert, but it's got lots and lots of loess deposits as well. Now, geographers will talk about extent, and there is a great extent, but it's not cohesive. It's not all together. So we've got spotty conditions here and spotty conditions here. And that's because we're at 30 degrees latitude, a high pressure zone with little water. So we're not aggregating this material down a river channel like what happened in Europe. And with that, this material is being picked up by the wind, and it's being picked up and deposited into these sheltered areas. So there is topography within Australia and the northern reaches of Africa. These are big, big continents. And as such, then it's going to have enough of topographical change to allow for this loess to deposit in sheltered areas where it's not going to move around. But unfortunately, it is a dry environment. There isn't enough moisture to support agriculture. So with that, this is your last slide for the semester. Study well, contact me as you need me, and good luck with all your finals this term. All right, thanks.